All right, so here we go, part 2. All right, so now we've come to converting moles to grams, grams to moles, moles all the way back over again, blah, 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 blah. All right, so right here, basically for these problems, what you're going to do is you're going to need to identify what unit you're starting in and what unit you want to end up in. That will tell you how many problems you have to go through, how many steps you have to go through, etc., etc., etc. So right here, what unit are we starting in for this part? Moles, right? So we're going to do 2.53 mole. Got to sneeze and then, anyway, so we're going to look at our moles. This is where we're starting at. Where are we ending up at? Grams, right? So we're going to look at grams. So in order to do that, are we taking the blue or the red? Red. So what goes on top? The molar mass of AgNO3, and what goes on bottom? 1 mole. Okay? So put in the molar mass AgNO3. That's 14 plus 48 plus 107.87. That's 0.01. All right, so that's 88. That's 15, 19, 169.88. All right. Really? Sweet. 88 grams. So you multiply those through, divide by the bottom, which is just 1, and you get some number that is greater than 169.88. All right. In fact, it's 2.5 times bigger than that, believe it or not. Anybody not get that? All right, good. Anybody got any questions? All right, good. All right, 14.32 moles of H2SO4. All right, again, so what unit are we starting in? Moles, right? And now where are we going to? Formula units, which is encompassed in which one? Particles, right? So we're going to take the blue track. So 14.32 mole, 1 mole, over 6.02 times 10 to the 23rd. Do I have to put in the molar mass anywhere in this problem? No. All right. So that's done. All right, this one, number 12, I'm going to do with you guys because this one's a little bit harder. And let me get this guy up here. All right, so this problem says convert 11.92 grams of K2O to number of atoms of potassium. All right, so this is actually 2 parts to a problem. The first part, what it's asking us to find, is the number of formula units of K2O. So in order to do that, whenever you see these problems, what you got to do 11.92 grams of K2O. You're going to do 1 mole, because you're starting in grams over here, you're going to moles. So it's 1 mole over the molar mass of K2O, which I believe is 94.2 grams. And now we're in moles, so what's our last step to go to particles? 6.02 times 10 to the 23rd divided by 1 mole. So you do this, and you end up getting 7.1524 times 10 to the 23rd units of K2O. Hang on. So you're going to do 11.92 times 6.02 times 10 to the 23rd in your calculator. Then you're going to divide that by 94.2. You come up with this answer. If you don't, that means you did something wrong. All right, but this is what you should end up getting. Now, how many atoms of K2O, or how many atoms of potassium do I have in K2O? I got 2, right? 2 atoms of potassium. So what I'm going to do is multiply this number by 2, and that gives me my answer of 1.43. Let me clean that up. So 1.4305, keeping my right number of sig figs, times 10 to the 24th atoms. Okay. Why do you multiply by 2? Okay, so the problem asks the number of atoms of potassium. So Whenever, let's break this down to something a little bit simpler. Let's say that I had 7 units of K2O. All right? So in order for me to have a unit of K2O, in order for me to have 7 of these guys, I have to have 2 potassium and 1 oxygen atom. Or if like I'm making a cheese sandwich, okay? 2 slices of bread, 1 slice of cheese. So total, if I have 7 cheese sandwiches, how many slices of bread do I have? I got 14 slices of bread. Now how'd you do that? Multiply by 2, right? So that's exactly the same thing here. I'm taking it, I figure out what it is from my formula. Yeah, that sounds like lunch money right there. Or soda at least. Alright. Anyway, so there you go. That's what you're looking at for right there. You just multiply it by whatever number it is inside the problem. Alright. That being said, I'm going to skip 13 and 14. And 15. Let's look at 16. Now, this is the type of problem that is going to be on your test tomorrow. And it's very important that you understand how to do this type of problem. Okay, now with this type of problem, this is like the one that we saw on the other page. Essentially what this is asking you to do 4 types of problems in one question. Now, if you want to do all the work, hey, more power to you. However, I am going to show you a shortcut, which you have to be able to understand the math reasoning behind it if you're going to use it. Otherwise, I'm sorry, you are banned from using it. You need to do the work. So I'm going to split this up and do A, a B, a C, and a D. If I have 4 moles of each of the substance listed below, in which case do I have the most mass? All right, so here's the dealio. What is going to be the same in all of these guys? Which of the 3 boxes is going to be the same? The 1 mole, and where's that going to be at? So if my box is labeled 1, 2, 3, 4, which number is going to be the same? Which of these 4 boxes is going to be the same? 1 is going to be the same because it's going to be 4.0 mole. 0.0, 4.0, 4.0. Unfortunately, you are not correct, Priya. It's not going to be the same. All right, so let's look at our 8 back there. That one. There we go. Come on. Come with me now. There we go. All right, we are starting off in moles right here, right? And we're going to what? Grams. So what's going to be different on top from number 2? Molar mass is going to be on top. What's going to be on bottom? 1 mole. And this one is obviously what? This box right here, the box 3. This box right here, empty. That's what I'm saying. 1, 3, and 4 are the same. All right, so the molar mass is what goes in here. All right, so now we're going to put the molar masses in. NaCl is 58.44. Why do I know that? I just do. H2O, everybody should know this one. What is it? 18.02. Good. All right, and all right, C, calcium chloride. What do we got for calcium chloride? That's 40.01 plus 35.45 times 2. So that's 70.9 plus 40. 70 is, let's see, 110.9? Is that right? Okay. 110.98. There we go. And then D is going to be what? CO2? All right, now, like I said, you can type all this crap in your calculator. Or you can realize, what's 50 times 2? 100. What's 25 times 2? Which one's bigger, 25 or 100, or 50 or 100? All right, so essentially this is what I'm equating to you. If you had 2, let's say 1 and then 25, 2, 1, and 50, which one of these guys, without doing the math, which one of these guys is going to give you a bigger result? The second one. Why? because it's a bigger number, right? So which one of these guys is going to give you the most mass? C, CaCl2, because it has the biggest what? Biggest what? Molar mass. Good. All right, now let's look at 17. All right, I'm going to break that up into the next video.